So first of all, myself Subrat Kishore Datta, I'm the DSC lead for Assam Engineering College. First of all, I would like to apologize for yesterday's lag. It was entirely on my part, so I just want to really apologize for that. So today we will just start this session on basics of image processing using Python, OpenCV. So I'll just go through the code, but before that, I'll obviously go through the theoretical part. And to make it a bit interesting, I'm taking a project to display those, and these are very basic. No filters are involved in here. So basically, it will be, I think, it will be very basic. Am I audible? By the anyone can confirm? Shashanka?
Yes, you're audible.
Okay, sure, no problem. So first of all, I will just first present my screen, and if anyone joins in, okay, okay, when you join, okay, yeah, we should do. Okay, okay, sure. I'll just present my screen. Okay, joining in. Hold on a second. Probably no more. Okay, thanks. Sure. Uh, so is my screen visible to everyone? I hope it is.
Yes.
Yes, it
Okay,
is.
sure. Okay. So moving on to this, we'll do the code part. We'll just ignore this right now and moving on. Okay. So welcome everyone. This is a very basic beginner session. Actually, it was directly intended for that. So it's fifth semester and the seventh semester people, you may come across things which actually you may have done, but I will go from very scratch as three third semester people are involved, so I'll just have to cover everything. So kindly bear with me for that. Okay. So today's agenda is basically going through two things mainly. First of all, invisible cloak project, and we will explain the entire concept that is involved in that, and then we will also explain the code that is used in that. And first, further, we'll go and do a bit of face detection using OpenCV. It is only to make sure that you can do certain things using OpenCV. To just give you an idea ki how what OpenCV can do, we won't go into depth of open face detection as a lot of things are involved using deep learning and everything. We will do in the further future sessions for sure. We'll obviously cover deep learning as it is one of the key interests of mine. So we obviously do that. So moving on to this, we'll just start the entire project. So this is the basically invisible cloak that is everyone is familiar with, right? This is the invisible cloak of Harry Potter. So it has a lot of designs in it, and it is brown and everything. But in real life scenarios, to use this kind of cloak, obviously it is possible, but it is basically anyone who have done some video editing or video processing, basically those go ahead and start with that. Okay. Before that, I'll just go through some of the few basic concepts of image processing. That is, first of all, we are going to go ahead and understand what is color space. So typically, the image that we capture are in RGB color space. That is red, green, and blue color space. Right? Correct me if I'm wrong. So that is basically we have three channels for a particular image. So basically we use that, and we have a corresponding values for a single pixel. We have three values. That is for one for red, one for green, and one for blue, and we combine those three to get the pixel value of the final output. But in this project, what we need to do is we want to segment this blue part, right? We're going to segment this blue part. We're going to detect this blue part. So we to get to to do the detection in a better way, what we're going to do is we're going to change the color space to HSV, that is hue, saturation, and value. So what H gives is basically gives the what color is it. It gives the basic idea of that. Saturation is basically how saturated is that pixel with that particular color, right? So basically, if we have a low value of saturation, then we have a grayish towards the grayish tone, and if we have basically a higher value of saturation, then we have towards basically whitish tone kind of thing. And for the value, basically, it is the value for like the brightness that is having. Okay. So and in image processing literature, what we do is like the region that we want, right? This is the blue region that we are interested in. This is basically known as region of interest that is given in. Hold on a second. Someone is joining, so yeah, I'll just admit that and go ahead. So basically, what we do is this is called the region of interest. This is called ROI. If I repeat this word, don't get confused. This is just region of interest. That is the region that we want. I think that is clear to everyone. Can you just confirm that on the chat section? Yeah, even one will do. Anyone? Or you can just unmute your mic to just confirm that. Okay, Cool. Okay, I'm getting some confirmation. That is very good. Okay, great. So moving on. What we are going to do is basically we are going to just get this segment right. So what we do is we do Hsv thresholding. Now, what is this thresholding? First of all, just look at these pictures. These two pictures we are having. So what we are going to do is we are going to get this white blue part, right? Now you can obviously see that in within this, if I just if I magnify this image, what you can see is in this region we are having a blue that is having a bright tone, that is white, more whitish kind of thing, and in this region we are having some dark tones, right? As you can see right here. So I got overlap, but I'm sorry for that. But yeah, that is what it is. So basically, for a particular color, we definitely have a range, right? So we basically have a range. That is, this is from light blue here to we having dark blue. So basically, there is a range involved in it, right? Uh, I'll just go and this on my camera if it is possible. Yeah, sure. So what it does is basically, so in HSB, we will have a, okay, hold on. I'm having an invitation. So yeah, okay. Okay, one more. Okay. Okay, sure. So what we do is basically we take a range within which this blue color is defined. So we're gonna segment this blue region. So basically we have a like a upper bound and a lower bound between which the pixel value of this blue region is basically enclosed, right? So this is what it is. This is the lower bound for this particular blue thing I'm having. And for people should not get confused if this code will work only with blue color mat or whatever color cloth it is. No, it won't. It will work with any colored mat or even any cloth you have. But the thing you need to make sure is that it should be a flat color that is easier to detect and do the processing with. And this lower bound and the upper bound will basically change. Okay. Uh, so what happens is this blue color is enclosed between this range. Okay, this is the lower bound that is H value of 64, S value of 74, and B is basically 0. And upper bound is 111 for H, 255 for S, and 251 for B. So basically any pixel having a value of HSB in between this range will basically be detected when we do the thresholding. And when we threshold, we basically mean that we are creating a map. Now, what is map? Map is basically an image where the region of interest, that is the region that we need, is represented in white, and the image part we don't want, that is represented in black. This is nothing racist, but this is what it is. Lame joke. Okay, ignoring. Moving on. So in this, the main part of this image processing is basically some of the basic operations that we are doing. First of all, I think the thresholding part is pretty clear. Can anyone confirm in the chat section, please? I'll just explain again if it is not, for sure. Is that clear, the thresholding part? Can anyone reply? Okay, sure, no problem. Yeah, sure, no issue. So this is clear. So basically moving on this, in image processing, one of the major thing that is we apply operations. Now what is operation? So let us understand that. So we have an image and we want to apply operation. And operation can be anything. Operation is anything which changes the pixel values of
so,
the.
But sorry to interrupt you, but someone has an.
Okay. Yes, please. Can you what you want? Can you just say me that? Okay, sure. I'll just explain it. Okay, fine, sure, no problem. Thanks, Jafar. Okay, thresholding. What thresholding means basically is we want, first of all, just understand this. We want to detect this blue portion, right? So basically, what we want to do is we want to get every pixel that is basically within this blue, right? So this blue color will be captured within a certain limit, right? Lower there will be a lower bound and there will be an upper bound. So suppose pixel blue is basically represented by the number 7, and also the dark portions is represented by number 8, and the light portions are represented by number 6. So basically we are only want those that particular region that we have, that is 7 6 7 8 only. Yeah. So when we want that, basically we have a lower bound that is 6 and an upper bound that is 8, right? So that is how we want to enclose within the range that we are having. So in thresholding, what we do, we only select those pixels which are having a pixel value of within that particular range. This is the range that is the lower bound, and this is the range that is the upper bound. Right? Within this range, if we have any pixel that is having that particular values of the set of values, any value of that particular set, then basically we are including it that in our threshold. Do you get, is that clear? Can you confirm, please? Juman, did you understand that? Or should I explain it again? I'll just do it again, no problem. Juman, are you there? Juman, is he present actually? Can Zafar cannot see, is he here?
He's in the group.
Okay. Juman, did you understand that? Okay. Juman, it's fine. Okay, fine. I'll just I hope it is clear and just move on as we have some time constraints here. I'll just explain again if he says. Just Zafar just take me out, okay? Okay, moving on. So basically we are going towards the operations. So basically what we have is we are having some basic logic operations. Okay, operations I've already have explained that. So operation is anything basically which just changes the pixel value of an image, right? So we have in our project we have used two operations. That is, one is the NOT operation and one is the AND operation. Now there is one word that is called bitwise. So maybe fifth semester and seventh semester, and the other people may know it, but third semester may not know it. So I will just go ahead and understand that. I'll just explain that as well. So in the operation that we are using, not operations, everybody, I think everybody has done basic logic gates, right? So basically, what in NOT gate, what we do, basically we just change 0 to 1 and 1 to 0. Basically, that is what we do. So in bitwise operation, we are basically having an array. So one more thing, basically, I just want to give the definition of an image in terms of image processing. Image is just an array of pixels. Okay, so basically we are having an array, 2D array, and that each element is basically a pixel that represents a pixel, and probably that is the HSV which is represented. So that is clear probably. So what we do is bitwise not what it does, it just changes each and every pixel to its complementary value. Complementary meaning if it has a 1, it is basically to change it to 0, and if it has a 0, it will change it to 1. But what it does is it just changes the corresponding bit of a bit value, right? If it is 1, this value is 1. That is, if we have a matrix that is A11 value is 1, then it will change A11 value to 0. I think that is clear. And then the bitwise AND operation. And AND operation, obviously, everyone knows about the AND operation. Because 1, 1 gives 1, and 1, 0 gives 0. And 0, 0 also gives 0. So in bitwise operation, you can imagine it like a multiplication thing, okay, in terms of image person. Basically, we are having a image. Image obviously has all the values. That is from 0 to 255, and you have a 8-bit system. 255 from that is 2 to the power 8, and you have a 256, which is 0 to 255. Okay, we are not going to that depth, so just ignore. So these are the pixel values. This is a pixel value that is having 125 value, and we do an AND operation, and that is basically a bitwise AND. So what happens is basically multiplies this value, this particular value with this value. So basically anything multiplied by 1 is basically the number itself. So basically you're getting 125 here, and anything multiplied by 0 in this corresponding value is basically getting a 0, and hence it is. So someone confirm that, is that clear? Please give a put on the chat window, please. Is that clear? Okay. Okay. I'm getting a response. That's okay. Okay. Cool. Thank you. So moving on to this, now we will just jump into the main flow of the entire, the invisible cloak project. So what we do at the initial level is just take a image of the background. Now the thing is, I will just make it clear. Obviously, you know that, but I'm just going to say this is nothing magic. So everything you do here is basically there is a process involved, right? So you need to go through that process, and this is what it is. Okay. So initially, at the initial level of processing, what we do is we go ahead and we take some background images that we want to overlap the blue portion that we cover later on. Okay, so it will be more clear to you after some time. We just take a background image initial level, and this is we represent it by BG. I think you guys should put a note on this particular initial. Probably I'll just come back to it. No problem with that. But yeah, you can just put a note on this. It will be easy for you. So it is the first step involved that we take some background images and we store it. Okay, we initialize them. Now the next thing is the processing starts. Okay, so basically you just come in front of the camera, right? And you bring your cloth, like your cloak, whatever you are having, you bring it in front of that. And the first operation that is done is basically masking. That is the thresholding I was talking about, right? So it just creates a mask of this particular image, and we get this particular image. So basically we are detecting for blue, and we get a mask which is basically having all its values as 0, oh, it is 1, that is the white values corresponding to the positions where we were having the blue color, right? So basically, anywhere in this image where we are having a blue color or a blue pixel that is turned into a white pixel in that particular mask. And you can imagine the mask as basically a image where we are having white and a black. White represents the region of interest, ROI, and the black represents the region that we are not interested about. And this is basically a binary kind of thing. Like if the mask works in a binary principle, like it is the white values are represented as 1 and the black values are represented as 0. So that is we are having here. So we are creating a mask right here, and we are doing a NOT operation to this particular mask that we have created to get the mask invert. This is very simple. The white portion in this mask is actually turned to black, and the black portion is turned to white. So that is it. And we're going to use this both the images. That is why we are just keeping an initial on it. That is mask is represented by M, and mask inverse is represented by M inverse, M INT. And this is the basically operation I was talking about. This is basically 1 0 0. That is actually I have already mentioned that this. If imagine this is the representation of this mask, and while inverting it, it will be having a pixel values of like this. Is this portion clear? Can anyone confirm? Okay. Okay, I'm getting it. Yeah, sure. No problem. Yeah. Yeah, I'm making some more. Yeah, thank you. Okay, thanks a lot. Yeah, moving on. So moving on, the next step we have is basically what we want to do. Now, get this straight. When the final image is basically this one, right? It is basically we want to like replace this particular blue region that we're having with the background image, right? That is background image, that is this one that we are talking about. So basically we need these two portions, right? These two portions is what we need. And we just want to add this and add this. I'll come to that addition, but before that, this is the thing. So what happens is we will do a AND operation. This is the frame, that is the input image we are talking about. Like this image we are having here, this is served as the input image here. Okay, and we are doing a AND operation with the mask inverse that we created, right? So we are having this, and we are having the mask inverse that we have just created, right? This particular one, yeah, this is that. So we do a AND operation. What we do basically do a multiplication of this is basically this particular image is obviously having some pixel values, right? It is clear because it is not black, totally black, right? So basically it is surely having some pixels. So basically what we do is we just multiply bitwise. We do a bitwise multiplication of this particular image pixels with this image pixels, right? So what we have a pixel value here, and black is obviously having a pixel value of 0. So anything multiplied by the 0, we're getting a basically what? We get a 0, right? So this is still black, and this portion we are having is having obviously some pixel value, and this is basically having a 1. Anything multiplied by 1 is basically basic mathematics. We get basically a pixel value itself. So basically we get this particular image. This is the IL we are representing. This is the input layer. That is the initial. We don't need to mind that for sure. We just get this, and now we have this image up here, right? Now we want to prepare this. That is a covered layer. So this is what initial is, obviously. So we have the background image, obviously this image that we have taken initially, if you remember. So what we do is we just take that image and we apply the mask over it, right? We just do an AND operation with the mask that we prepared initially. This is the initial mask we created. This is the first step we did, right? So after that, what we get, do the same AND operation, and you get the required region of interest here. As I have mentioned, in this particular sequence, this is the region of interest that we are having, right? So this is represented by a white in this position, and hence we are having this region of interest. In this particular sequence, we want this portion to be covered, and hence we are having like this is the white colored portion that we need, and hence we just multiply this with this one, bitwise multiplication, and we have this covered there. So I think that is clear. Is this two operations clear? Anyone can confirm, please? Okay, full form. Okay, this actually, the full form actually is not a good. I just given some initials. That is input layer. It is since this image is input, so basically I just turned it as input layer. There is nothing like important you need to know. I just put it there this way because it will help in the code for the nomenclatures, and so it will help that way. So you don't need to mind those as of now. Just is this concept clear of the particular two operation that we did? Can anyone confirm about this? Okay, sure. We're getting some responses out here. Okay, got it. Good, great. Okay, the last thing we want to have, that is the last operation that we want to do to create this particular miracle as of now, is this to add this two image that we created and just add club them together, right? So we just want to do a bitwise addition. So what is bitwise addition? Simple as that. We are having some pixel value here. Obviously, this is black, so basically we are having a 0. We are having some pixel value here since we are having the image something. So basically, it will have some pixel value. So basically, we just add them two together. So basically, A11. Suppose we have two matrices, that is IL and CL. Then IL's first pixel, that is IL11, will be added with the pixel of CL11. Is that, I think that is clear? Very simple addition. That is nothing more than complicated than that. And we get the final images. So this is the basic concept of the entire project. I hope this is very clear to you. That now we will just move on to our like the the application, like the coding part. So till this, if anyone have doubt, you can just clarify for me right now. And is that clear? Yeah. So if anyone have doubt, you can just write in the comment section if you are feeling awkward to just unmute. But you can obviously unmute the thing. Okay, is that clear? Okay, fine. Sure, no problem. Okay. So we will just move on to the coding part. Okay. So first of all, I'll just like to cover few things actually that is important for I think third semester because they can get confused about this. So actually, I got obviously for when I was starting. So what is there is one thing called Python ID. Okay. This is what okay. There are multiple platforms. This is the ID is really platforms. Okay. The environment. This is I forgot that total name. Ignore that. We are having multiple platforms where we can run our code on, right? We have Spider, Python, Jupyter Notebook, Google Colab is there. Python ideally is data that python.org or AI that is provided. So we have multiple kind of like multiple platforms that we can run our code on. I don't prefer. I just do it on Spider because I have been doing it for a long time. Now I don't go to there. So basically, only few things changes regarding installations of packages and all that. Nothing changes. It is same in everything. We just run the Python code. So it's just same in everywhere. So basically, the code that is run on Spider will obviously run on Python as well. But when you are using Google Colab or I think Jupyter as well, I have not familiar with I think yeah, Google Colab, few things changes when it comes to OpenCV. I think in our next post we will link the videos which will assist you to that or some articles will assist you to that. I'll just link them. And then Python ideally is just the one provided by the Python itself. So these are some ideally. So no need to confuse over this all these names. Basically, you can use any one of the following that you can use. Okay. So I think that is clear. So this so now we will just go on directly to the coding part. Okay. So moving on to this code. Yeah. First of all, this is the code. Okay. So I think the code is busy. Okay. Anyone confirmed about this? And the first say me what is the response?
Yeah, it is.
Yeah, sure. Okay, fine. So first of all, you need to go ahead and run these two things. If you don't have Python Python installed, obviously you need to install them. And OpenCV, you will need OpenCV. So if you don't have OpenCV installed, then you can go to like I think if you're doing on Python ideally, then you need to go on CMD and run this particular thing. It's pip install OpenCV dash Python. And if you are on Anaconda, like if you are using Spider, then you can just go to Anaconda prompts and yeah, probably here, and you can just go ahead and write this, run this particular set of code. And similarly, you need NumPy. I think many of you have NumPy. So basically, just if you don't have, then just go ahead and run pip install NumPy, and you will get the thing. So, so for the third semester paper specifically, okay, I'm speaking about this part. So I think all of you have done for this C in your first semester or second semester. Can you just confirm? The first in like the first semester paper specifically. Yeah, sure. Okay, you have done C. So in C, obviously you do one thing. Okay, let me just go ahead and do this. You write one code that is basically hashtag include stdio.h. I am sure you have done this thing, right? What is this? Basically, what you do is basically you just import this particular library that you are having offered by C. Okay, the printf function that you use to print something, printf, yeah, that is basically a function within this particular library. So basically, you cannot use this particular function unless and until you do this, you run this command, right? You need to run this command, and then only you can use this printf function. Basically, what it signifies? Basically, this function that you are doing, this function is within this particular library, right? So in Python, we don't do hashtag include. What we do is we do import. It is the same thing for getting include, and that is include is basically import in Python. Okay, just get it straight. So what we want to do is we want to import two libraries here. That is, one is CV2 and one is NumPy. And one best part about Python is that you can actually name those libraries. I think you can do it in I think you can do it in the C as well as in the aliasing. But yeah, in this you just need to put an as, and you can just do give any name, or like any name can be there. So basically, many people do it as you can actually go ahead and see many of the codes are like it is done as CV. Basically, you will see CV dot some function. Basically, the CV2 is imported as CV. I think that is clear. So basically, what we do is, yeah, what we do is basically this part is basically we are importing the libraries, necessary libraries that we need in our due course of our thing. The next thing I want to explain is about objects. So fifth semester, and I think not everybody, but yeah, object-oriented programming is the like a paradigm of in computer science. That is basically, hold on a second, yeah. So what it is basically, object-oriented programming. One is there is one concept called class and object. We are not going into the class thing right now, but if I want to explain to you the object thing, then it is basically suppose there is a human race, right? We are having humans, and we are having individuals of it. Like I am an individual. Jafar is one, Sashanka is one, as I'm talking about the core members of our team. So basically, these people, we are multiple people, right? So basically, we are in computer science, we will be termed as objects, right? So we have one object that is named Subrat, Zafar, and Sashanka. We have three objects. Now, this particular object will have their own jobs to do, right? Because I will be an engineer, so I will have some engineering tasks to do. I will have some engineering jobs. So basically, that is my job. And a job can be defined in any programming as basically a function, right? This is basically a function. So, so that is basically it. So, moving on to this part, what we do is we create an object, camera object. So this is done basically directly by CV2. CV2 library have this function called CV2, the video capture. The within bracket we have 0. Now, what this 0 signifies is that this basically talks about that we are basically declaring that we are using the webcam that we are having. So if you have multiple cameras attached to your system, then it will be having the field 0, 1, 2, and so on. So this video capture basically initializes the camera that we are having. Just okay, sure, okay, no problem. Okay, so this is what it is. So camera is basically a virtual camera. You can imagine, like so you can just imagine that. Hold on a second, I'm doing this. Request to just shut my camera. Yeah, for sure. Okay, so is that clear? Can anyone confirm about this object thing? Can anyone, if anyone have doubts, then I will love to clear that up. So if anyone has doubts, then I'll just clear it up. Is that clear? Okay, yeah, it is clear. Okay, that is really good. That is really good. Thanks. Great. So this is the basically object thing we are having. So this is basically a virtual camera that you can think about as a camera, right? It's simple as that. So now what we are doing is we are initializing a variable. Now this, if you do on C, basically we will be having an int behind that. But in Python, the beauty is you don't need to define that. They just know, because you are basically assigning a 0 to it. So what else it can be? But yeah, that is what it is. So this is the okay. Now I will do one thing. I'll just split the screen between two halves so you get a better idea about the code. Hold on a second, and I'll just pop the So here it is. The parts here. It remains clear. So this is the thing that we are doing right here. In this particular thing that we have here, this camera.read. So you can imagine that the web camera is basically clicking an image, right? So basically this is clicking an image, and this is set as a background, right? So basically we are having this background. This is the particular step we are doing here. So we are going for 10 iterations because sometimes what happens is by initializing the camera, the first image that we take is not that good. So we need to go for a look and just get the image. So it is better you can just play around with this number, particular 10 numbers, to get a better idea about what it is. So you will get this particular background. Okay. So now what we do is the next step is involved. That is, we want to resize this thing. So basically what we use is we just take a function that is present in CV2 library. That is, we just resize the input image. That is, background is the input image that we are having, and we just resize it to a value of 10 cross 10. That is basically pixel with the width and the height. Right. So this resize function takes in two arguments. That is the source image that we want to resize, that is the background right here, and this is the size we are having. So we assign this new image, the background image, to this new variable that is called replace frame. We are naming it right here. Is that clear? That anyone can confirm about this? Is that clear? Till this portion? I can, yeah. Okay, I'll just go ahead and just say it again. Okay, no issue. Okay, penetration. So the thing is, whenever you just take whenever we just go for penetration, this is simply because sometimes the camera takes time to initialize. Okay, so basically we are going for 10 images, like penetration. This is basically we are going for 10 images, right? We are taking 10 images at a time, like not at a time, but in 10 iterations we are going for 10 images. So after like 10 images, the camera gets settled in, so basically we get a better image. Sometimes that's happens when the camera is getting initialized and the code runs, and before the camera gets initialized with the picture is taken, so basically you don't get a very good image. So sometimes it can be dark all around. Okay, so basically what happens? So what we do is we take 10 images and we go for the last image. Okay, you can actually play around. This can like if your processor is very fast, then it can actually work like on a single image as well. But for our sake, we are taking 10 images for this particular thing. Is that clear? Naved Reddy, is that clear? Oh, sure, no problem. Great. Okay, that is the main thing. Moving on. So this is the main thing that we are doing. This is the basically processing start from here. Okay. So we will just not do that right now. Okay, okay. So this is what happens. So the first thing we're gonna go ahead and we just wanna get this input image, right? We're having right here. We're gonna get this input image. So what we do, we just go ahead and again do the camera the read thing. We just get a new picture coming into the loop. So basically we get this input image. And again we do the same resize thing so that we need to like fit this particular background into this. So basically we should have the same like size, right? So just we go ahead and just resize the image, the input image that we're having right here. Uh, this is the frame that we assigned it to, the same variable. So basically it will be having the same thing. So after that, what we do is we change it to which, yeah, okay. Oh, hold on a second.
Question I said about chat box.
Okay, what we use before, okay, we use dash before all the objects of okay, let me check it around. Okay, okay, this part, sure. I'll get to love to do it. So what happens is this cam dot like this dot read function we are having, this returns two values. Okay, so first value is basically is the camera working or not. That is basically a boolean value, 0 or 1. If it is 1, it is basically working. If it is 0, it is not working. Yeah, that is it. And the second value that returns is the image itself. So in Python, what we do is whenever we want to ignore and return value that is returned by a function, we go ahead and just type an underscore right here. Okay, so this is the basic concept that Python is as far as Python is concerned. I think that is clear, Bhushana. Okay, sure, great. So we do that. Okay, so now we have already mentioned that somewhere, right? Hold on a second. Yeah, what we have mentioned is that we are changing the color space into HSV, right? So to do that, the CSV like the CV2 library has some direct function. So basically we can just do the convert color function, that is dot CV2 dot converter. By the way, look at this one thing. This CV2 okay, CV2 dot we are using again and again. This is because we are taking this particular function from the CV2 library. Okay, so that is why we are using CV2 dot the function and hence the other argument. So this thing should be clear. Okay, don't confuse on it. This is not a very great thing. So just get it. So in this convert color function, what we do is basically we take in two arguments again. This is basically the source that we want to change. In this part, obviously, we're going to change the frame into the HSV format. And this is particularly the operation that we're going to do. That is the color DGR to HSV. Oh, yeah, one more thing in CSV is very important. That is, in normal literature, we term it as RGB, that is red, blue, green. But in terms of like CV2, that is OpenCV, what we do is we take the channels in the reverse order. That is blue, green, and then red. Okay, whenever do any operations regarding this, like whenever there is a operation which involves like segmenting the channels, then you need to be very clear about that. That whenever we are having the first channel, that is obviously blue. Then we have green, and then we have red in case of OpenCV. I repeat, this BGR thing is specific to OpenCV and not to others. Like if you are using Matplotlib library or something like that, then it is again there it is RGB. But in OpenCV, it is BGR. So whenever we do an operation which involves basically change of the color space or whatever it is, then you wanna do grayscale image or whatever it is, we do BGR to CSV or like HSD or BGR to gray. So this thing is, I think this is clear. Okay, this is a catch about OpenCV. There's nothing interesting about it. Is that clear? Anyone has doubt about the BGR thing? Can anybody confirm about that? I hope it is clear. Okay, great. Okay, awesome. Okay, now what we do is we go ahead and now this is the HSD image that we are having. And why we do HSD? This is one tricky question. Like we can obviously go and stick with RGB as well. Like there we are also having pixel. The thing is, in HSD, it is somehow easier for the computer to segregate. Okay, in RGB we are having three channels, so basically we need to consider three channels, and actually it's kind of tricky because the things get add up. So basically it's kind of tricky in RGB to do the segmentation part. So basically I won't go into the depth for that, and neither you should. So while thresholding, we are always using HSD color space. So basically what we do is that. So for our blue, since we are segmenting a blue region, so basically the upper bound and the lower bound are basically declared here. This is the lower blue. That is the lower bound for the blue color that we are having, and we basically simply do an array. And because array, that is an NumPy array, you can just whoever have done C just imagine to be as an array. NumPy have some additional, some additional benefits of doing this. Of using the array thing, but just imagine it to be a simple array we are having. So we just give it three values. That is the H, this is the S, and this is the V value in the lower section that we are having here. So this that we are having here, I can do that. Yeah, we are having here. And for the upper bound, we are again declaring another array. So basically, we are using this upper blue kind of thing. So, but I want to just ask everybody one thing: am I going too fast or what? Okay, Jeremiah, can you hear now? Jeremiah, can you confirm please that you are hearing or not? Others are hearing, right? Can anyone confirm? Okay, yes, we join. Okay, sure. No, okay, sure. Okay, great. So we are going again to the coding part. Okay, moving on. So I think this lower bound and upper bound is clear to everybody. We are just declaring two arrays out here so that we can just put it in this. Okay, sure, no problem. Sure, no problem. Okay, this is the camera. Okay, so I'll just go ahead and just explain to you everything again. Okay, so HSD basically we are doing what we just changing the color space from RGB to HSD. Okay, that is hue, saturation, and value. So basically, what we do here is basically since we have the upper bound and the lower bound thing, we have already explained that. So basically, we define here two arrays. Okay, so this is the this is the array for the lower bound, and this is the array for the upper bound, right? So these are the values H and S, and this is the V. So these are the upper bounds. I think, is that clear? Kulendra, is that clear? Okay, sure, great. Moving on. So now we are what we are gonna go through. Like we just want to get our mask. The background image, yeah. We're gonna get this mask right here. So what we do is mask. For mask, we do a simple function in CSV that is CV2 that is in range. Okay. So in range function is a function from OpenCV, as you can see here. So it takes in three arguments, probably, but yeah, three arguments. That is the HSV, that is the source of which we want to find and map of or like mask of, and this is the lower bound that we are declaring here, and this is the upper bound. Okay. So basically, what we are doing is we are feeding the HSV image that we have just converted, and we are putting a lower bound and an upper bound on it. Okay. So basically, this image function produces a mask. Okay. So basically, what it does, it goes to each pixel and it checks the value of H, S, and V. And if that particular value, that particular HSV value is within this particular defined range that we are having here, then it will change this particular pixel into the mask in which it will be having a white color pixel. And if that value is not within this range, then it will be having a value of black, like that is the black color. It will be having a pixel value of 0. This is the how we create a mask. Okay, so this function basically creates a mask. Is that clear? Can anybody just please confirm that, as it is very important? I'm going to. Is that clear? Creating mask, or should I explain it again? I'll just go through it again if it's required. Just give me confirmation on the chat box. Yeah. Okay, sure. Okay, now just go ahead again, do it again because couldn't do it. Okay. So what it does is CV2 the in range is a function from the in CV2 library. Okay, that just get this clear. So it takes in 3 arguments. Okay, that is first is the source of the image that we want to put the mask on of which. Okay, so it takes the HSV image that we have just created. This is the image, and we put in the 2 bounds that we are having. This is the lower bound and this is the upper bound. Okay, so how it changes into a mask? Mask is basically having a 2 values, like 0 and 1. This is basically an image, but the region of interest is turned into a white color, and the region of interest that we are not interested in, that is turned into a black. So what happens is, since we are interested in the those pixels which is having a value within this particular bound, that is the lower bound and the upper bound, what we do is we just we check for every pixel in this particular HSV image, and we check whether that particular pixel is having a pixel value which is within this particular bound that we are talking about here. Okay, if that particular pixel have a value within this particular range, then in the mask image that we are creating, that value will have a value of 1. That is basically it will represent a white color, right? Okay. Okay, so it will basically represent in white. And if we are having and suppose if that particular pixel is not within that particular bound, then it will be represented in color flex in the mask. Is that clear, clearly? Can you just confirm, please? Is that clear? Okay, sure, no problem. No issues. Okay, we again pop the screen. Moving on, we want to create the mask inverse, that is this particular image we are having. So we just go ahead and we just do a bitwise NOT. Now bitwise NOT and AND operations are directly provided by OpenCV, so this is very kind of simple thing to get attached to. So this is just CV to the bitwise NOT, and we put the mask that we have created here and just put it here, and we get the mask inverse image. Okay. So the next image will be kind of improved. Okay. Okay. Moving on to this. Hold on a second. Oh, great. Hold on a second. This might just tighten this now. Just wait for some seconds, okay? Yes, okay. Okay. Now, okay. Now we're just gonna increase the size of okay. Okay. Now the next step is basically we are creating this IL and CL thing, right? Now, obviously, we have done what we know. One, we want to do an AND operation in the input image that we are having and the mask invert that we have just created, right? So in the IL that we have variable that we have here, what we do is basically we do a bitwise AND operation, okay? And it takes 3 arguments. That is, the 2 of the arguments are basically first 2 are basically source that we want. That is obviously the source is basically this image to which we want to apply the mask to, and the third argument is basically the mask that we want there. So we have the mask, and the mask is mask inverse. So basically we assign this particular value this, and we do a bitwise AND operation, and we get this IL. And for in this case, the IL is this one. Okay. Then again for the CL, it is the same thing that we are having here. That is, we have the background that is basically represented by replace frame, and we just do an AND operation with the mask that we are having. Okay, so mask, in this case, the mask is this particular variable that we have just created. So we just assign the mask to mask, and the source
Please,
that, yes.
please zoom.
Okay, okay, wait, hold on a second. Yeah, hold on a second. Okay. Is it visible?
Yes, right.
Okay, sure. So with the first two arguments are basically the source image that we need, that is replace frame. Obviously, the background color. Now we want to do this particular like operation to the background, right? So basically, we take the background image, that is the replace frame we are having here. We just declared there, and we put in these two particular arguments here, and we just do the mark thing. Okay, we just put the mark there, and we do a bitwise AND operation, and we get this particular value, that is CL, right? So really what we have here, okay, let's do this. So now at the final, as the final step was concerned, what we did was we basically added this to IL and CL, right? Can anyone just confirm that IL and CL are clear in the coding part? Yeah, go ahead and just clear that, confirm that. Okay, okay, that's good. Okay, cool. Okay, sure, I can just explain it again, no problem. So what we did was we have the frame, right? We have the input image that we have right here, right? This was the input image that we had. Yeah, this was the input image, right? So what we want to do is we want to add the mask to it. So the mask inverse that we have just created. This is the mask inverse as we are talking about. Yeah, this is the mask inverse we are talking about. So basically, we want to just do an AND operation between the frame, that is the input image, and the mask inverse that we have just created, right? So this is the thing. So this is the basic operation, as you can see here. Hold on a second. Yeah, yeah, that's way better. Just okay. So we are doing just the AND operation between these two images. That is the input image that we are having and the mask inverse that we have just created, right? This is the mask inverse that we just created right here. Yeah. So so we will do a AND operation. Now in CSV, like CSV not. In OpenCV, what happens? There is a like direct function is there. There is bitwise AND function, and what it does is we just does the AND operation, right? So we just feed in, these are the arguments. Okay, these three are arguments. Now bitwise AND operation of OpenCV takes in three arguments, right? So the first two are the sources of the image, like the image to which we want to apply the mask to, and the third is basically the mask argument itself. So basically, we just in this particular IL for IL, we want the source to be this particular image, and we want the mask to be like the mask inverse, right? So say we have the mask inverse, right? So we do an bitwise AND operation, and we just get this IL, and we do the same thing with CL. So basically, we do a bitwise AND with the background image that we are having. Now, in this code, we have defined the background image to be replaced frame. So basically, we take in replace frame as the two arguments of the first two places, and for the mask, we take in the mask that we generated. That is this particular thing that we have generated here. Is that clear? So actually, can you just confirm me that? Okay, great. That is great. Okay. Now after that, we just added this two. We have created IL and CL for sure. Then now what we want to do is we just want to go ahead and just add these two images. And for this, we will use cd2.add function, and it does some bitwise addition, and we get the final image that we want to see right here, right? So it does this, and I am showing basically it will pop up a window which will be having a name of image, and it will basically show this particular image that we have generated right here. This is the CG that I am show, which will basically show you the magic happening right on your screen. So and now we are having a infinite loop, right? Because there is a true right here. So basically it will move on for continuously for like infinite time. Now we don't have that much of time. So basically we will just get out of this loop. Now how to get out of this loop? We want a break operation. For people who have done C, we do the same thing. That is, we just put a break operation, right? To come out of that. And what we do is like we have a function right here. Well, now when we want to get out of this loop, so what we want to do is we want to make a function right here. That we just want to make a command right here. That whenever we press the like the key Q that on the keyboard, then this particular loop will end and our video processing will stop. Right. This is the basic idea. So what we do is we go ahead and write this wait key it is inverted from a bracket that is 10. Now wait key basically is a function offered by OpenCV that this is basically this is a function which wait for a keyboard interrupt or basically any keyboard key to be pressed. And this 10 basically signifies 10 milliseconds. That is, it will wait, a processor will wait for 10 milliseconds for a to receive the keyboard pressing, like keyboard interrupt. And whenever it is pressed, and whenever that particular key is Q, which is basically an AND operation, like this is a basic logical operation that we are doing here. Whenever that particular press key is basically Q, then what we do is we just come out of this particular loop. So this is what happens. Okay. So now again we just release the particular. These are basically formality of OpenCV we are mentioning here. Camera the release. Basically we are releasing the object. You just don't need to go about into that in this depth when you actually whenever you do OP, then you will obviously learn that. And this is the way destroying all windows. Basically whatever window that we have created during the program, we just delete those. So I'll just go ahead and run this code. But before that, I'll just gonna say a few things. Is that is this code clear? If it is not, then I am willing to explain it. But okay, basically OXFF is basically is this just taking in an keyboard interrupt that is pressed. That is what is a variable kind of thing. You just don't need to go into details about that. This is what it is. Basically, you just press some key, and whenever it is assigned to OXFF, and that is basically a command, right? So basically, whenever it is having that particular condition is met, it just breaks the loop. So I don't think you need to go into depth for this as of now because this is just a command that is lying there. So it is basically. I hope the code is clear. Is that clear? Okay, good. And okay. Now I'll just go ahead and for the code, there is some few formalities out here that at the initial level, as I have already mentioned, that the camera will take some time to get some background images. So basically, I'll just move away from the camera, and I have my map going on here. So basically, I'll just go ahead and do that. Okay, just hold on a second. So it is going to take a few images of the background initially. First of all, the camera initialization takes some time, so it will take some time, I guess. So the screen should pop. Hold on a second. Yeah. So just pop right here. Okay. Now if I come here, now if we do this particular thing, that is the math I'm having. Okay, now you can see here very clearly. Now my headphone was having a blue color, right? So it has just done the same thing to the headphone itself. So basically I'm having the math here, and if I do this particular thing, I'm just kind of invisible. I think you can see this, right? So that is what it is like. So that is how this thing works. So I think you people like it. I just hope you people like it. And whenever now I'll just hit the Q button and this screen will just vanish. This Q button is pressed and this program ends. Okay, so I just hope you guys like this particular session, and we will be having one more part. So can you just confirm? So you are doing the same thing. I think you don't have your OpenCV installed, and don't worry about the code. Okay, I'll just install that. I'll just go ahead and upload in the GitHub that we are having. So I'll just give the link for that. So don't worry about that. Uh, okay, I'll just do that. And by the way, I'm just gonna give you my contact so that OpenCV is installed. Okay, what's your code that is you're getting? Can you just confirm me that?
Argument code is required to be an integer.
Can you just go ahead and say it again, please?
It's a type. I'm getting a type error. Like it says, argument code is required to be an integer.
I think you're having an issue with the numpy thing. I think here. Okay. So do me one thing. I'll just give the context right here right now. Okay. Just you go ahead and just take those contacts and just connect with me for the code. I'll just resolve every code that we're having. So anyone can just note this thing. That is my number, phone number. This is my email, and you can just go ahead and just contact me there. I'll just solve all your problems. That I can guarantee you that. So this is it. Okay, just for Juman, I will say that you just go ahead and collect these things and just just take a screenshot of this and just contact me. Okay, I'll just solve the problem. Okay, is that okay? Roman, is that fine?
Can you please repeat? I didn't hear you.
Okay, so what you do
No,
is
I
you just
didn't
take.
hear you.
Okay, now is my voice clear to you now? Hello.
Yes, now it's clear.
Okay, you just go ahead and just take a
Yeah, now
screenshot of
it's
the.
clear.
Okay, you just go ahead and take my contact. This is my phone number and this is my the mail, and just go ahead and there's no contact with me. I'll just solve your problem. Okay.
Okay, thank you.
Okay, no issues. Okay, so this is the thing. So I think for the remaining people, I think it's clear. So okay, okay, good. Okay, for the remaining people, is that the code clear? Okay, great. So what I'll do is I'll just upload these things into my GitHub repository and I'll just give the links in the next post. So basically, just don't forget to go to the handles, right? So go there and just follow us in there and you can get this. Now Sudarshan will do a little like a session on face detection. Now I'll just give a few briefs on the image detection the face detection thing. So he will just go to the code. Okay, for this is basically because the phase detection actually is a complex algorithm, right? To do it on your own, you just need to go through a lot of things because a lot of things are involved in that. It is first of all, you have your detection thing going on, and then there is a part which is localization, which is actually very important to put the bounding box, right? So we will obviously organize some sessions on deep learning. So basically, we will clear their the doubts, right? So basically, now I will just want to show you the basic part of basic mindset of using showing you this is because we want to show that using OpenCV you can do the face detection and actually use the implement the face detection part for various things. Like I have one project robotics going on where we do some perception stuff. I have used the OpenCV directly for that because it is very easier to do that way. Sometimes I have trained few models on myself, but they are kind of slow, so just I just go ahead. I just went ahead and do that stuff. So that is kind of advantage of using OpenCV that you can actually concentrate more on the project and when you are having case direction only as a part, and then you can go ahead to do this part. So basically, that's the main mindset. So I think Sudarshan will take over then, and he'll explain that part. Sudarshan, are you there?
Yes. Hello.
Sudarshan, yeah, you're audible. Go on.
Uh, okay. Good evening, everyone. I am Sudarshan. Sudarshan has already given the introduction. Now I am going to explain the code part. Actually, I am going to code it now, and I am using her cascade front-end phase XML file. Now let's see. At first, I am going to import OpenCV library. Then I am going to do the first video capture part. Then I am going to the detection part. For video capture, first let's create a object, camera object to capture the video from the webcam. Now this is the object I'm using cv2 dot video capture function. Here I'm here I have written the parameter 0. What it will do is it will automatically detect your webcam as your camera source. If you have more than one camera, then you can put 1, 2, and so on. Now I am going to analyze frame by frame, so I'll put it in a loop so that I can get the frames. I'm using cap.read function, which will give the frames, and the arrays variable will get a boolean value if the if we are getting successfully video from the webcam, then it will be true, otherwise it will be false. Then after getting the frames, I'm going to show the frames using cg.amShow function. Yes, frames. Now it will continuously take the video and put a terminating condition. So I'm going to write a loop function for termination. cv2.e. Actually, this function is already explained by Super. This will wait for a 1 millisecond. The 1 means I'm going to wait for 1 millisecond, and if some key is pressed from your keyboard, then we'll end the condition. Sorry. If Q is pressed, then the loop will end. Now, after ending the loop, what we will do is we will release the capture object. This was all about the video capture part. Now, if I run the code, then it will capture the video from webcam. Here you can see, I think. Is it visible?
So the screen is visible, but your
Yes.
like video feed is not coming.
Okay. I think I have to present as. Okay. Hold on a minute.
Yeah. No.
Is it visible now? Yeah. The camera running and it is continuously capturing this. Yes. This cap function capturing the cap object, capturing the from the webcam. Then we reading the frames. Then this condition for the terminating condition for this loop. Then there is correct. After pressing the Q, the camera stops working. Okay, now let's go to the detection part. Here, I'm using the cascade classifier, her cascade. Uh, uh, we're using cc2 dot cascade classifier function. Here, we are going to put the path of the XML file. You can see it is in the my working directory. This is the XML file. I'm going to take its path and going to paste it here. Okay. Then we are converting its frame to grayscale from DZR. Actually, Subodh already told about DZR format in CSV in OpenCV. Uh, Now we are converting the frame to grayscale using cp2 dot cpt color function. Then we are passing frame and color underscore dcr2 grays parameter. This will convert the frames in DZR format to grayscale format. Then doing the detection part using this cascade classifier. Then here I am using detect multi-scale function. Here we are passing the frames in grayscale. Then I'm passing 1.1 as a parameter. Actually, this value, actually, this is the scaling factor. What it will do is it will decrease the size of the frames by 10%. The 0.1 means it will decrease by 10%. If you put 1.03, then it will decrease the frame size by 3%. But its importance is it will the smaller the size of the frame, that it will be easier to the comparison part using detector as uh, then using another parameter minimum neighbor. I'm passing it to the say if I mean if we put 0 here, then we will get too many false negative, false positive. Then if we increase it, number of false positives get reduced, but we may miss true. So you can study more about. Then what you to do is what it will give you detect multi-scale. It will actually give a rectangle type structure where the faces are located. Then if I'm putting a condition here, if length of those rectangle type structures are greater than 0, then we are going to throw a rectangle type structure around the faces detected. For that, I'm going to write then we are going to draw a rectangle where the face is detected.
Just repeat the like the when Rishika is asking, can you repeat why cascade classifier is for? Can you repeat the cascade classifier? This is the multi-class part again.
Cascade classifier is used for detecting the features. I mean, it was an earlier method where it is going to detect the human face by eye position, nose position. Actually, we need a detect classifier to classify those parts Here we are using Hsv detector. Actually, this is not very efficient method. You can go for deep learning method. There you can get better accuracy. It is not that much correct, but it is easier to use. That is why I am using it here. Actually, we are planning to do a session on deep learning. Then there, I think we can show those methods. Okay. Now I'm going to draw the rectangles over the detected case using CV to the rectangle function. You can draw a circle or any structures by using CC2 library. There are dot circles method, dot other methods are there. I am using here rectangle. Here we are using frame as a parameter. Then the XY values. Uh, these are the coordinates of the rectangle. Actually, we will get it here x, y, w, and h value from the code. Then um, actually what these will do is you have already know that in OpenCV color format is BZR. Here 255 means it is B value, and G and R values are 0, so means it will be a blue, and this location signifies the color of the rectangle. So I am using blue as the color of the rectangle, and another parameter I'm putting it 2 here. This signifies this. This will give the width of the rectangle. This was all about the detection part. Now you can go and run check the code. So now here, okay, getting a C2 dot. Okay, now you can see it is detecting my faces and drawn a actually it is dynamic size. You can see because I have written it as XY value. So you see bit of the rectangle changing. And that's all from my side. If you have any doubts, I'll put the code to GitHub.
Thank you, Sudarshan. So, few of the things that I would like to mention in terms of like hard basket things. The one thing is that it is not that much robust. Okay, like so when you're doing frontal face detection, basically when your face is not towards the front, like on the face part, then it can actually detect some like not very good, not very good accuracy. Okay, so put that note while putting for implementations specifically for this particular hard basket thing. So you can just do that. Thank you for this, for attending the entire session. We are actually very glad. Further, we also have coming up one more session that is on 11th. So I would like to, so we will basically, yeah, sure, we'll just share those on our handles. So don't worry about that. We'll just do that. We'll just do it as soon as possible. We're just updating our, GitHub for that, like basically adding the comments on those. So we'll just surely provide those. Don't worry about that. So thank you for attending. And basically, we have on 11th we have a talk on research, basically on AI. So this is to be provided by Dr. Konkona Bora. So basically, I think we will announce the register link and all that. But for some basically people who are actually interested on for the research part, so they can actually join in. They will very interesting. So you can go ahead and do that. So thank you everyone for attending, and it is very great session, and I hope you all like it. So thank you so much, and we will probably provide the the feedback forms as well. So thank you so much.